MCQ 23 is a mini structural elucidation question. So let's just take a look at each of the different clues. First one, we do know that W is a carboxylic acid. That means that there should be the presence of COH that is found on W. It comes with a molecular formula of C5H10. And another crucial clue for the case of W is that it is considered to be chiral, meaning that we should be able to draw it out to generate a chiral carbon. So this is a 5-carbon long carboxylic acid. So the first thing that comes to thought here is actually a linear pentanoic acid. But you can see that in this linear pentanoic acid, there is no chiral carbon. So what we're going to do, we're going to shorten the chain by 1 to draw a butanoic acid. And if I were to place my side chain over here, you can see that once again there's also no chiral carbon for this particular butanoic acid. So let's go for a positional isomer of butanoic acid. But this time around, putting the side chain to be closer towards the carboxyl group. And with that, we generated a chiral carbon. So this suggests to us that this is going to be the case for W. Now, if you take a look at the end structure of Y, all of them has a common functional group, which is the generation of an amide function group. So in order for us to go from carboxylic acid towards amide, it's important that we actually go for the purpose of nucleophilic substitution to generate an acyl chloride. Now, reason being because my amines, which is being used in general, is considered to be a Bronsted Lowry base, and the carboxylic acid is a Bronsted Lowry acid. So there will be neutralization that's actually happening, and it might interfere with the formation of the amide. So from W to X, we're going to go for PCl5 anhydrous for a nucleophilic substitution to generate an acyl chloride. So with a PCl5 over here, anhydrous, we're going to get our acyl chloride. Of course, with our side chain over here, still preserving the chiral carbon. So combining with the structures that is given in the question, which is actually a cyclic amine, we will be generating an amide functional group. And this is also with the elimination of HCl. So in this case here, going to take a look, we have our structure X being generated. What we're interested in is actually our structure Y over here. So going to A, B, C as well as D, it's really obvious that for this particular question here, we should be looking at A to be that as our answer, because we do have our chiral carbon being preserved, similar to what we're seeing in the structure over here. But if you take a look for B and D, there's already no chiral carbon that is being generated. No preservation of chiral carbon from molecule W. So B and D, they are wrong by themselves. And for the case of C, there's actually the lack of elimination of hydrogen to combine with chlorine to form HCl. So once again, the correct answer for question MCQ 23 will be A.